Good morning, everyone. This is Isaac, and today we're going to be reviewing the fourth chapter in our Java walkthrough, which will be detailing classes in Java. Um, this part's going to get a bit technical, but not too much. If anything pops up during the class that you don't understand, feel free to drop a message, drop me a Slack, and we'll review together. So for now, let's just go ahead and get started. So classes in Java. In previous programming studies, we've encountered classes and objects. Nothing new here. Classes and objects in Java are similar to classes and objects in other languages. So minimal class and object. Classes contains fields, as we see here, and methods, as we see here. Fields contain our data for the class, and methods define actions a class can take. We say that fields and methods are members of a class. Okay? So in this sample, we'll create a class hello world with one field, message, and one method, say hello. Message will be a string, and we'll have the value of hello world. Say hello will not return a specified value, and instead just print it out. So we'll go ahead and do that in IntelliJ real quick. We'll do a new, well, I think we already have hello world ext, but let's just go ahead and do a new class. And we won't add that. And what we will do here is we will just do what we were instructed to over here, which is public string message hello world. Yep. Okay. And now we will include a method to print out the message. So we'll do public void, and we will call this method say hello. And this will be a printing of our message. And when we run this, it should just print out hello world. Well, actually, we can't run this. And the reason why we can't run this independently is because we don't have a main method. So this is actually considered a class that has to be called by another class. Yeah, somewhere around there. Okay, so let's go ahead and head back to our reading now that we've created our class. There we go. So the only field in the hello world class is message. Well, the only method is say hello, which prints the value and doesn't return anything. So here's the same note that I just said. There is no main method, which is required to run a Java program. Without it, we have to do some additional work to get our program to run. To say hello, we'll need to create an instance of the class hello world. We refer to an object created from a particular class as an instance of the class. So here's how our hello world, this might look with our hello world class. So when you create an instance, it's kind of like when you declare a hash map earlier. It's the instance type, the instance name, and then new, then the instance again. So we can actually do this in our hello world runner. Let's go ahead and do that in IntelliJ. So we will do another exercise. Hello world runner. And now we're going to do to actually run our main, I think it's public static void main. We're going to do our string arguments. Okay, so that should allow us to run since this class has main, but this one right here does not. So we'll go ahead and just call this one. So we have our class name here, hello world. So hello world sample is equal to new hello world. And let's go ahead and run this. Why did that not work? Well, yeah, because we're trying to print out an object. So instead of doing that, and that is my apologies, we can do sample dot, and we can call the message directly, or we can do say hello. We're going to do say hello just because that's what we're trying to run. And now when we run it, there it is. We get hello world. So nothing too groundbreaking there, just a generic class over here, and its runner here where we just call a new instance of that class. We'll go ahead and head back to our reading. All right. So in order to call the say hello method of hello world, we have to create an instance. We did the new hello world, as well as building classes that we create define their own types. So the object hello is a variable of type hello world. We introduced this hello world class to illustrate the simplest representation of some basic concepts in Java. So this keyword. In hello world above, we could have written say hello with this way with the same effect. Public void say hello, system.out.println, this dot message. I want everyone to keep that in mind, and we're actually going to copy this and paste it into our IntelliJ, but we're going to comment it out. All right. So in this context, inside of the class, we can refer to the fields and methods that belong to the class using the special object this. Whenever you use this, it always refers to the object that the given code is currently within. In other words, this will always be an instance of the given class. So since it's not legal to create code outside of Java, this nearly always makes sense to use. You're allowed to create local variables declared within a method, with the same name as a field of a given class. In this case, we must use this. So let's actually take the sample and work it. Let's see. Copy. And let's go into IntelliJ. Okay. And we can actually get rid of that. Okay. So we have our public string message, hello world, our say hello. Now, one thing to note here in say hello, we have another string message, which is goodbye world. If we do system.out.println message, we're going to get goodbye world, because this right here, the message that isn't highlighted is referring to the local variable within this section right here. However, if we do system.out.println this message, this refers to the higher class, which is hello world as a whole. So this message will refer to the message inside of the hello world class. Just keep that in mind. And if we run it, let's see if it'll actually. Well, let's try running it. See what happens. Did not like line 28 because I think we have an extra. There we go. Okay, let's try running it now. Yep, there we go. So as you can see, the first line, since it was this local message right here, it printed goodbye world. And this right here, this message right here, since it did use the this word, which belongs to the whole, not just the local, it printed hello world. So it can get a little confusing. Just keep the this operator in mind as we move forward, and we will continue. Okay, so when a local variable has the same name as a field, we say that that local variable shadows the field. Errors caused by shadowing can be tricky to spot, so it's best to avoid doing this in your code. And yeah, we're good. Okay, so check your understanding. The following code contains several bugs. Mark all of the lines that contain a bug in the code. This is a great instance for you to actually use your IDE to inspect this. So we'll copy this and we will swap over to our IntelliJ. And we're actually going to comment everything out here. There we go. And we're just going to paste. So as you can see, it's already letting me know, hey, something's gone wrong here. So let's go ahead and see. So we're missing this little red line right here lets me know, hey, you're missing a semicolon. And here, if we hover over it, cannot resolve symbol here. So we'll do this dot name. And let's try, instead of public class greeting, let's just do public class hello world. There you go. And if we run hello world runner, let's see. Yep, so now it's running successfully. So if we swap back over to the exercise, it looks like the lines that were failing out were line 3, because that's where we needed our semicolon, and line 6, because instead of here, we actually needed this. All right, let's go ahead and proceed to the next piece, modifiers in Java. For fields in classes, the access level determines who can get or set the field value. For methods, the access level determines who can call the method. So for fields, access is who can get or set it. For methods, access is who can call it. The access level of a class member is determined by an access modifier. We've encountered access modifiers in our code. In our examples, you can see public. Public makes a field or method accessible by anyone working within the code. Another common access modifier is private, which restricts access to the fields so that they can only be used within a class. There are 2 more, though they're used far less than public or private. So here is our hello world class, except instead of having public, well, hang on, let me pull up IntelliJ right quick. There we go. So they just printed out our hello world class, except instead of having public void say hello, as you can see here, even though it's commented out, they just have void say hello. So here they omitted the public access modifier in lines 3. So the string message is no longer public, and 5. So line 5 is no longer public. Doing this implicitly gives the message field and the say hello method default access. We should avoid giving everything default access when creating classes in Java, and instead think carefully about what level of access each field and method should have. We have a table here that just kind of gives you what is allowed and is not allowed depending on your modifiers. You have public, protected, no modifier, which is value, private. Here's just a couple of samples. A field with a private access modifier can be accessed within the class, but cannot be accessed outside of the class at the world level. So in Java, world level is the level of the whole application and contains all packages and classes. We can save this table. Honestly, this one's kind of limited, so I just Googled a different one. And let's see. Let's just take these 4 as the tried and true levels of access. Okay, so let's take a look at our hello world class. So public class hello world, we've made the private string message hello world and public void say hello. So since message only needs to be used by say hello, we declare it private. Since we want say hello to be usable by anybody else, we declare it public. So as we can see from this class up here, private means that it'll be accessible in that class and only in that class. Public means that it'll be accessible in the class, in the package, and in the world. Okay. So a couple of notes here. In Java, you should always use the most restrictive access modifier possible. Minimizing access to class members allows code to be refactored more easily in the future and hides details of how you implement your class from others. This makes your code more modular and modifiable. Each public member that you expose is another field or property that can be referenced directly. elsewhere in any program using your class. Thus, changing any such field in your code could potentially break any code referencing such members. The fewer public members, the more you can change your code without breaking stuff in the back. Just keep that in mind. Essentially, I don't have a great way to explain that without getting into my code stuff that I do for work, and I don't think y'all or my job would be too happy with that. So we're just going to skip past that. So let's just check our understanding. For this question, reference the block below. We have public class greeting, string name just, public void say hello, system.out.println, hello, this.name, exclamation point. So what access modifier would you give name? In this instance, if we scroll up, we can see here that we gave the string message private when we referenced it in our class. And the same holds true. So the name would only be referenced in this class potentially. So it would need to be accessible by the class and by the class, potentially by a getter and setter as well. So I would honestly almost want to say that, let's see. My apologies, that was my text tone. Let me silence this phone. All right. So yeah, honestly, I would say private would be acceptable for string name just, since it only needs to be used by this public void. So I would say C, private would be good enough for it. Let's proceed to encapsulation. So there are 4 basic pillars of object-oriented programming, which are abstraction, encapsulation, inheritance, and polymorphism. Encapsulation here is like your first foray into this, but encapsulation is essentially bundling of related data and behaviors that operate on that data, usually with restricted access to internal, non-public data and behaviors. So in Java, classes and objects allow us to encapsulate or isolate data and behavior to only the parts of our program which are relevant. Restricting access allows us to expose only that data and behavior that we want others to be able to use. We're going to look at student real quick, but encapsulation, and this is a very, very oversimplified illustration, but it is kind of like a capsule. You have your class, which is the whole capsule, and inside you have your variables, your methods, and your class. Well, your class is kind of like the capsule itself. So just keep that in mind. I think we were right here. Okay. Sorry, have multiple tabs open. So we're going to look at the student class. And so we previously defined field as a variable or a piece of data that belongs to a class. For our students class, we would think about the data that we would want associated with a student, whether he's high school, middle school, college. Well, that the number of credits would be most as far as high school or college. But we would have name, student ID, number of credits, and GPA. So in order to declare these fields within our class, we would need to best determine the best data type for each. A field may be of any primitive or object type. In this case, the following types will work best. We have string for name. We have int for student ID, which makes sense. For number of credits, we have int. Remember, int will actually allow us to do 2.5, etc. So even half credits are covered in that. And we have GPA double. The reason why we would do a double for GPA is because GPA can be very granular, like 3.777, 3.75, etc. So let's put those inside a class. While they may be declared anywhere within the class, the field should always be declared at the top of the class. When we're ready to add the methods, we'll add them below the fields. So we're going to actually create our student class in IntelliJ. Exercises, new Java class. Okay. Okay. There you go. So now we have our public class student string int, and double. Let's swap back over to our book. Okay, like variables within a method, these fields can be initialized when they're declared. For example, we could provide default value for number of credits and GPAs. Well, for example, we could provide them for name and student ID. Okay, so for example, we could provide default values for number of credits and GPA. Default values for name and student ID don't make sense since they should be different for each student. So we could do int number of credit equals 0 or double GPA equals 00. Fields are also referenced instance variables since they belong to an instance of a class. Okay. Getters and setters. As declared, our 4 fields are package private, which means that they can be read or changed by any code within the same package. As a rule of thumb, fields should always be private unless you have a very, very good reason not to make them do so. So we'll make our fields private, and we'll pull back up IntelliJ. Go, and we'll just make these private. Okay. All right, let's pull back up our workbook. Okay. In order to provide access to private fields, getters and setter methods are used. They do essentially what they say they will do. Getters get a value in a field, setters set the value to a field. So if we make a getter and or setter for a method for a given property public, then others will be able to access or modify the field in that way. So here's the getter setter pair for name, and we can imagine how the others would be written. There's actually IntelliJ is very intelligent in a sense that it will actually give you a way to just automatically do your getters and setters. You can right click, and I wish I knew why this place really did not like seeing that. But essentially right clicking, going down to generate, or you can click Alt Insert. Will get you this pop-up. And let's see if I can. Of course. I love that. Okay. Generate, and you can. There's a drop-down section here for getter and setter. I'm not sure why OBS isn't picking it up. Okay, there we go. Now we're cooking. And okay. There we go. So here, after you right click, you drop down to generate and you select getter and setter. It'll tell you, hey, what do you want to get and set for? You can select 1, 2, select all, and OK. Boom. All of your getters and setters generated with a couple of clicks. Now, it is good to get your own practice with this, but that's essentially a quick way to do that. So you have a getter for name, you have a setter for name, getter for student ID, setter for student ID, getter for number of credits, setter for number of credits, getter for GPA, and setter for GPA. Easy enough. Let's go ahead and swap back over to our book. Okay. So prefixing a parameter that is intended to set an instance variable with a is a relatively common convention and will adopt to avoid shadowing. And having to use this in our setters, you can think of a's as denoting the argument version of the variable. So a good question would be, why make the fields private if we're just going to allow people to get and set them anyway? There's a couple of reasons why. First and foremost, sometimes we will want to implement behavior that happens every time a field is accessed, get, or changed, set. Even if you can't think of a reason when you're writing your class, you might need it at a later time. It's not uncommon. So if you don't use getters and setters, you'll have to do a lot more code rewriting and refactoring to get them to work correctly. We can perform validation within a setter. So if we want to ensure that a student's name contains only certain characters or that their student ID is positive, that would be some validation that we could do on the setter with some regex or some if statements. And we can use different access modifiers on getters and setters for the same field based on desired usage. So if we want to allow anyone to be able to read the value of a field, but only classes within the same package to modify it, we could do this with a public getter and a package private setter, but not as a field without getters and setters, which we could only do public for everyone or package private for everyone. Okay. Let's continue. As an example of reason 2, let's take a short detour to look at our temperature class. A valid temperature can only be so low, absolutely 0. So we wouldn't want anyone to set an invalid value. In set Fahrenheit, we print out if a value provided is invalid. So let's actually go ahead and create this. Let's see, we'll swap over to IntelliJ. Okay. All right. So here you have your private double, you have your getter for Fahrenheit, and then you have your setter. You have a static value for absolute Fahrenheit, which is absolute 0 Fahrenheit, and then you have a check which says, hey, if the Fahrenheit is less than absolute 0, print out value is below absolute 0, then set it. So nothing too much there. Let's go ahead and swap back over to our book. Actually, can we, I wonder? Okay, let's try it. Let's do temperature temp is equal to new temperature. Okay, and we will do temp dot set Fahrenheit, and we're going to set this to negative 500. Let's try running it. Now it threw the error, value is below absolute 0, because negative 500 is definitely below the negative 459 that we had set. But if we change it, let's say that we pass negative 400, it won't actually return anything, right? Just because it's just making the changes in the background here, but it's not asking to print anything out. But if we do temp.get Fahrenheit, and run it again, oh, I didn't print. There we go. And now let's run it. Negative 400.0. So our getters and our setters are working as expected. Let's go ahead and continue. Okay. Note, when writing getters and setters, the convention for a field name is field is to be named get field and set field, which we can definitely see over here in our IntelliJ that we have get name, get student ID, set student ID. So the convention is currently being observed. Okay. It's more than just a convention. Some libraries will expect names to be of this format and won't work if you don't follow it. Fair enough. Properties. A property in Java is a characteristic that users can set. Our student class had properties name, student ID, number of credits, and GPA, while temperature only had Fahrenheit. We've confirmed that. Most often, properties will be fields that have public setters, though they may not always have they need not have a corresponding field. Let's look at an example above that doesn't directly correspond to a field. If we wanted to add a Celsius property to the temperature class, we might want to do this. Okay, so let's do this. Since there's a link between Fahrenheit and Celsius, we want to make sure that when one is updated, so is the other. In this case, we only store one field value, Fahrenheit, and make the appropriate calculation when getting or setting the Celsius property. So that is weird, because we have a reference to Celsius here, but okay. So here, public double get Celsius, just as Fahrenheit minus 32 times 5 divided by 9. Public void set Celsius, double Celsius, is a double Fahrenheit where it equals Celsius. So whatever argument is passed here times 9 divided by 5 plus 32. And then set Fahrenheit is set to Fahrenheit. Note, there are slight variations among Java developers when it comes to colloquial usage of the term property. People will sometimes define the term in a slightly more specific or narrow way to mean a private field with public getters and setters. So using properties, getters, and setters, and fields, we can encapsulate the information we need in our student class. So question, what is a method that is used to give a private field a value? Setter. All right, let's move on to constructors. So we'll often want to initialize or set the initial value of some of our fields when creating a new object from a class. Constructors allow us to do that. In Java, constructors have the same name as a class and are most often declared public, though they can have any other valid access modifier. They are declared without a return type. Any function that is named the same as a class and has no return type is a constructor. So here is a sample of a constructor defined within our Hello World class. And we can actually recreate this in our IntelliJ. Let's go for it. So let's see. There we go. All right, so let's go to our Hello World class. And let's just delete all of this extra stuff. We'll do private string equals hello world. Why does it not like this? Let's see. Because I did not give it a name. Oh, I deleted too much. That's why. We're just gonna copy this. Yep, I did delete too much. Okay. So private string message hello world now works. We will actually now get our getters and setters. And we can actually generate that and our constructor. So we'll do getter and setter first. Okay. Boom. We have our getters and setters. Now we'll actually generate our constructor. We can generate the constructor the same way. Doing Alt and Insert gets you that same generate, and click constructor. And let's see if I can actually share this one. This one. Oh, you can see it. That's great. Okay, good. And yep, so choose fields to be initialized by constructor, message, okay. And you'll see how now we have a public hello world string message. This message equals message. So here you have your constructor and your getters and setters. All right, let's swap back over to the book. Okay, the constructor allows us to create a hello world object with custom messages. The assignment this message equals message assigns the value passed into the constructor to the field message. Here's how we might use it. So let's try this. There we go. And we are, instead of doing this, we're going to do hello world new is equal to, oh, nope, we can't use new because that is a restricted word. So sample is equal to new hello world. Hang on. I might have messed that up. Let's see. No. So we pass our variable here. Hi, Georgie. And if we print our sample, then let's see what happens. Okay, so this is another good thing to note. The reason why this is printing out this way is because I'm trying to print out sample, which is a reference to our hello world object, when instead of printing out sample, I should be printing out sample.getMessage, which will get whatever we've inserted here in our message. Now, if we run it again, yep. So we can confirm here that when we did hello world and we passed in this argument, parameter, whatever you want to call it, it actually assigned it there, but we have to use our getter to actually get that to print out. So let's go ahead and continue with the rest of our stuff. Let's go back to our book. Okay. So it's not required that every class has a constructor. If you don't provide one, the Java compiler will generate an empty constructor for you, known as default. So if we left out a constructor in our hello world class, the compiler created the following for us: public hello world. While this can be convenient, you almost always want to provide a constructor. Overloading constructor. So you can also provide multiple constructors for a given class in order to allow for different initialization scenarios. This is also known as constructor overloading. When providing multiple constructors, we must ensure that each has a different collection of arguments as determined by the number, order, and type of arguments. So looking at our class, we're actually going to do two different constructors, and we're just going to copy this first piece here. So let's look at our student. And we're going to paste this. And this would be this dot name equal name. This dot student ID equals student ID. This dot number of credits equals number of credits. And this dot GPA equals GPA. So that's our first constructor. But so in this scenario, this constructor would work if we had students transferring from other schools, whatever, that had number of credits to transfer and a GPA to transfer. Since there are also new students that might not have this information, we would do another one, public student, with our name and their student ID. But we would initialize their number of credits and their GPA with 0. So we wouldn't actually need any more. We wouldn't actually need any more arguments here. So we would do this dot name equals name. This dot student ID equals student ID. And then this dot number of credits equals 0.0. And let's just do 0. There we go. And this dot GPA equals 0.0. There we go. Okay. So now when we call either of these, they should work. So let's try it. Let's do a student Sam is equal to a new student, and we'll pass in our exercises. Well, our arguments, which would be Sam is the name. The student ID is 1, actually. Student ID. Number of credits, let's say that they have 3. And let's say that their GPA is a 4.0 because they're amazing. So when we do this, it will actually generate a new object for student named Sam with these parameters. Currently, it actually won't be able to get it because all of our getters are so split up, but we can also right click here, do another generate, do our getter and setter. Okay, yeah, I don't know. Maybe because we can't. No, we should be able to. Let's check something. Hang on. I mean, the getters and setters were omitted in the book as well, but let's just try to see if it does exist by just getting the name. So we're going to do, we're going to print out sam.getName, sam.getStudentID, sam.getGPA, and sam.getNumber of credits. So we run this. String cannot be converted to int. Error 643. Oh. Yes, it did want us to pass those in as strings. Okay. Let's run it. Okay. So the issue was that we were declaring int, and double as strings. Okay. Now, let's say that we have another student whose name is Joe, and they are a new student. But I mean brand new. Like they have no transfer credits, they don't have anything. So we're going to do Joe and we're going to give him the ID number 2. And that's it. Now we're actually going to just copy this, paste, but instead of Sam, we're going to do Joe, 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 and Joe. All right, so now let's try running it. So as you can see, Joe still printed out. Joe 2 with a 0 GPA and 0 number of credits. Reason being, we overloaded our constructors to account for both a transfer student and a regular student. Well, a new student. So that's a quick rundown on overloading constructors. So the first constructor allows for the creation of student objects, where the code creating the object provides the initial values for each field. The second one allows for students objects with only name and student ID. The first constructor would be useful for creating a transfer student, but the second one would be for a new student. So a better way to write the above constructor would be this: public student string name and student ID. And the reason why this is the case is because we can actually pass all of these in the same way we did up here. Okay, let's continue. In the example on 17, we use this to invoke another constructor within the same class. In this case, the second constructor calls the first within the default lines. So here, 17, we use the this to invoke another constructor, the one on 8, in the same class. And the constructor calls the first with the default values for the number of credits in GPA. So this is referring to this constructor with the same information, just with default values for 0 and 0. If you use this syntax, the call to this must be the first line in the, oh, I'm not sharing that screen. I love it when that happens. So there we go. This is a better way to write it. So here you have the same student, but you have the public student, where instead of having to write all of this out, you just do this name, student ID, 0 and 0. So here, this calls on the same constructor as line 8 and passes the same arguments, except instead of doing all of this, you just pass in the name, the student, 0 and 0 for your number of credits in GPA. This is a good practice because it makes your code shorter and it allows initialization behavior to be carried out beyond just initializing variables to be contained within a smaller number of constructors. In other words, constructors can share initialization code. Notice that this sample that a constructor doesn't require an initial value for each field as an argument. So when defining constructors, you should think about which fields must be initialized for your class to work properly. Which fields should be initialized by the user creating the object and which should be initialized by the class itself, and what are the use cases for the class you're providing for. So check our understanding, true or false, a constructor is required for every class, false. Okay, taking a look at the class called dog, public class dog, private string name breed, public dogs, string name breed, this.name breed name, this.breed breed. What line of code would be appropriate for us to declare an instance of the dog class called myDog and give it the name Bernie and the breed Beagle? So both of the name and the breed are strings. And the dog myDog, remember here it says we have to call the class myDog, so C is already out. myDog equals new dog. One thing to note here is we are passing in strings, so Bernie would have to be in double quotes, so would Beagle. So the correct answer for this is B, and we can actually test this ourselves. Let's just copy the code, and let's swap over to IntelliJ. And we will do a new class called dog. We're not going to add it to there, and we're just going to do this. Okay, done. Now, what we're going to do is let's do a getter and setter for name and breed. Well, yeah. So we're going to right click, we're going to do generate, we're going to do getter and setter, and we're going to generate one for name and breed. Okay, done. Now we're going to swap over to our our hello world. Yeah, that works. We're going to comment all of this out. And we are actually going to take our very same argument here from our workbook, which is B, copy, and paste into IntelliJ. And now, as you can see, it automatically detected the name and the breed. And now we're going to do a mydog dot, well, let's do a print statement. And we're going to do mydog dot get name. And then we're going to do another print statement called, that's referencing mydog dot get breed. Now let's print this out. Well, run it. And we have Bernie and Beagle. So the correct answer for that one is B. All right, let's keep it going. So now we have methods. Calling methods on objects. A method is a function that belongs to a class in Java. All procedures must be part of a class. Let's revisit our Hello World class. Hang on. All right, my apologies for that. So let's go ahead and continue. We have one method in this class, which is say hello. In order to call this method, we have to have an object created from the Hello World class template. So we have to have an instance of it, which is very much all right. So, which is pretty much the same as having our item over here in IntelliJ. So before we used the mydog, we had to create a new instance of it. We passed in our variables. That's the same thing that we have to do with our hello world. We have to initialize it, not this one, sorry, with the one in the book, my bad. Okay, there we go. So we have to create an instance of hello world before we can call say hello. And here's how you can call methods in an object. Hello world, hello equals new hello world, hello dot say hello. So it's not possible to call say hello without having the hello world object. This begins to make more sense when you note that the message field is used within say hello, and unless we're calling say hello on an existing object, there will be no message available at that point. Okay, so as mentioned before, class members should have the most restrictive level of access possible. This goes for methods as well. For example, if you create a utility that should only be used within your class, it should be private. You can think of private methods as those that are not useful outside of the class, but can contribute to internally to helping the class behave as desired or expected. All right, instance methods. So far, we've only looked at examples of methods that are relatively specialized: constructors, setters, and getters. Every class you create will have these methods. What will make these classes different from each other and thus fulfill the purpose of creating each class are the specific behaviors. Let's say we want to add a method to our student class that reports the GPA of a student. This method is an instance method since it will belong to each student object created and will use the data from each such object. So where's our GPA? So public string student info. Return this name has a GPA of this name. We will make use of this instance methods more in the next chapter. However, we wanted to share more about them now in our first conversation about classes. Sometimes when we create a class, we will need that class to have more behaviors than using only constructors, setters, and getters can provide. When we do want to add additional behaviors to our classes, we can use instance methods. So we'll check our understanding real quick. Fill in the blanks with the appropriate terms. A blank gives a class property to a field. A setter gives a class property to a field. It sets it. A blank gives a programmer access to the value of a private class property. A getter A blank creates a new instance of a class with the values for the field, a constructor, and a blank is a method that belongs to each instance of a class. Now, this is kind of weirdly worded because it could be an instance method, as we see here, but it could also be a static method. So keep those two in mind. But yeah, it's a weirdly worded fill in the blank. But let's continue. So single responsibility principle. As we wrap up our whirlwind of our classes, tour of our classes, we want to make sure that you think about how to go about building good classes. Doing so is more of an art than a science, and it'll take you a lot of practice and time. However, there are a few rules that we've pointed out. Here's one, which is the single responsibility principle. It states that every module or class should have a responsibility over a single part of the functionality provided by the software, and that responsibility should be entirely encapsulated by that class. So that isn't always clear what responsibility over a single part of the functionality means, but it's often clear what it doesn't mean. So if we're doing like add functionality to a student class, so we would do functionality that would add student to the student, like, hey, track the GPA, which we did in the past. That's functionality makes sense to live on the student. However, we wouldn't want to add functionality to the student class that tracked all of the data for each student's classes, such as catalog, number, instructor, and so on. That would probably live better on like a syllabus or something else, or a daily schedule, whatever, class. They're clearly different areas of responsibility. So one way to interpret the single responsibility principle is to say that classes should be small. As you go forward, the main thing to keep in mind is that your skill and judgment in creating Java classes will improve over time. The best way to improve is to write lots of code, ask lots of questions, and continue learning. Yeah, so I want to kind of add some more attention to this last piece. Write lots of code, ask lots of questions, and continue learning. This is key to learning anything because, I mean, you can show up, you can watch all these videos day in, day out for however long you want. But really, the best way you're going to be able to do any of this is by putting your hands on that keyboard. It's by learning about this by doing. As you hit roadblocks, you're going to have to Stack Overflow a couple of questions. You're going to have to do this, you're going to have to do that. But that's the best way to learn. Hands-on experience is honestly the best way to go about this. Just put your hands on the keyboard and type, man. And if you don't know what to do, then just go through regular exercises. Go do LeetCode, HackerRank. Those are awesome problem-giving sites that will help you get ready to understand more concepts, and they really push you out of your boundary. If you're still on that basic level, go to Free Code Camp and do some of the tracks there. They will definitely give you a deeper understanding to what you know and what you don't know. And yeah, just get to it. With that being said, though, we have reached our exercises portion that will be released at a later date because I'm not a huge fan of giving the answers out like in one fell swoop. But for now, just keep it going. Thank you for joining us. Thank you for watching. If you have any questions, comments, or concerns, please feel free to leave a comment or reach out, and I will get to you as soon as I can. Thank you very much, and have a great day.